Okay, lab 11, you're going to take your old array class that you did back in lab 9, or lab 8, sorry, in lab 8, and you're going to add the search routines and the sorting. What?
He was just talking about how something in lab 8 wasn't working.
Oh, well, you're going to have lots of fun with this one. All right, notice we're adding search, which returns the index of the array where the value is found, return 1, -1 if it's not present. And then you can run bubble sort. And the regular search should do a linear search. The binary search does the binary search where you are allowed to assume that it is sorted. In other words, linear search, you cannot assume your array is sorted, but binary search, you are allowed to assume that. And of course, run binary search to sort be ordered from least to greatest. Hopefully y'all can do binary or bubble sort, sorry. If any of y'all are not able to write bubble sort, you need to see me as soon as possible. Because we're going to need a very serious talk. Okay. Performance, we are going to do a quick performance graph for this. I wrote most of the code for this lab. So I will tell you right now, it is not perfectly correct. It's not going to be a simple copy and paste into your lab. You're going to have to think about a couple of gotchas that may be due to the implementation that you chose for your array class. So make sure you test it. It may copy in, depending on what you did, or it may not. You got to figure that out yourself. Do write a graph for linear versus binary search. Hopefully it should have array size at X and time on the Y. Make sure you label it and turn it as a PDF. Your graph should look something like this. Erase this. Linear search, and then depending on how far out you go, it's going to be something like, and then it's going to look like a flat line all the way across. All right, that's what you're going for. Naturally, this may be a little jiggly due to, I'll just say a lot of artifacts that can occur. All right, autograder. Part 1 is the code, which is what the autograder is going to give you 100 or a 0 on, or maybe possibly something in between. And then I will do it for part 2. Do not use anything from the STL. Don't even use vector, because I'm basing it off of your lab 8 implementation. I want you to show me that you can do it off of the lab 8. Obviously, don't call sort from the STL. That's just cheap. Go ahead. Again, if you can't write bubble sort, you need to talk to me as soon as possible. Push it to GitHub, and we're good to go. This should be due a week from today. Good, week from today. Any questions? All right. I like to ask the class this. Do you want your midterm before or after spring break? Sorry. Was that a before or an oh?
I don't know.
You don't know?
That's a very make or break question. Do we have labs due over spring break?
Oh, of course. And a project. What type of silly question is that?
Oh my god. Before, so you get like a break.
I feel like after.
Yeah.
I don't know. That's
I don't know. I'm feeling.
shoot. I mean, it'll make a difference.
I personally think you should do it before, because that's one less thing hanging over your head.
What is the midterm going to be like? Like, what's the style of it?
So there's going to be 2 parts to the midterm. The first part will be a short answer on Blackboard, and it'll be maybe 5 questions. The second part will be a coding where you're going to go, oh, actually, normally you do it HackerRank. This time we're going to leverage a senior project, and you're going to do basically a programming competition where you submit and get answers back.
What?
So you are making sense, but then just stop.
You said, what did you just?
Have you ever used HackerRank?
No.
Nope.
No.
Oh, this website is the best thing ever. I love this website. All right, HackerRank. Sure, algorithms. Oh, let's pick something easy. Implementation. Grading students. Sure, I've never seen this before. Let's go look at it. At Hackerline University, a passing grade is any grade 40 points or higher on a 100-point scale. Sam is a professor at the university and likes to round each student's grade according to the following rules. Okay, the difference between the grade and the next higher is multiple of 5. Wait, next higher, multiple of 5 is less than 3, round to the next highest. Okay, great. The grade is less than 38, don't bother and give them a failing grade. Okay. Oh, this is easy. Okay. Input. First line integer in number of students, and then next in lines are the grades. All right. Well, this seems easy. Sure, what should we write this in? Whoa, he gave me a bunch of code already. No, ignore this person. We're doing it our way. All right, even though we're going to write the same exact thing. So let's go ahead and create a vector of n. We'll call it grades, not of n. Oh, that was silly. Of integers. We'll call it grades. We'll initialize it to n. For int I equals 0, I is less than n, which we're getting from the command line, I plus plus. We'll go ahead and read that in. Okay, there we go. This is you in your exam right now, coding.
So we could get a problem like this, or we could get a problem like totally different.
Yeah. Oh, you're not going to be this easy. No. First grade is 2 below the next high, a multiple of 5, so it rounds to 75. 67 is 3 less, so it doesn't round. Okay. All right. So now we're going to do for int I equals 0, I is less than n, I plus plus, int grade equals grades sub I. Okay. So if grade mod 5, I don't know, it's equal to, let's see, what are we going to do? Equal to 4. Oh, I should actually say it's greater than 3. Now we'll do equal to 4. Then we'll do grade plus equals 2. Plus equals 1. That's silliness. Otherwise, grade, if its mod is 3, we'll add 2. And then what are we doing? Do we just print the grade out afterwards? We just print the grade out. Okay, sure. All right, let's run the code. All right, no return statement and function returning non-void. That's because we don't need our loser functions that this guy wrote.
Okay. It's holding us back.
It was holding us back. We failed. All right, let's see what we got. 70. Your output. Were we close? 40. Oh, so the last one should have been plus 2. Hey, why did that not happen?
Because if it's less than 38, then yeah.
Oh, I see. Okay. All right. So we'll do this. If grade, you said less than 38? All right. And by less than, I actually mean greater than or equal to. Then we'll do all this right there. That's great. And let's go and at least make this pretty. Boom. Yay, we passed the test case. Submit the code. Hey, looking good so far. Go, go, go. Hooray, I get 10 points. All right, so that was, okay, 2 minutes. It'd be like that. Obviously, your problem's going to be a little more complicated, probably involving a data structure we just did. But I'm not going to give you a project level problem on a test. I will give you a simpler problem on your exam. Yes?
Other like CS tests I've had, short answers like a 1-line code. Are you going to do something like that, or like an actual
No.
like short answer?
Short answer, I'm asking, the first part will be concept questions. What's the big O of this function? When would you use this data structure over another, stuff like that. We'll get into that a little more, but here you'll actually be coding stuff up. Any other questions? By the way, this website's great. That was an easy one. We go into graph theory, number theory, all sorts of different dynamic programming, all sorts of different things. Nothing? Okay. So we're doing it before midterm? Before spring break. Got it.